Okay, so if you've never seen inside of a sensor before, like this one, this is from a DDR sensor. This is where we're kind of getting that FSR type feel from. Okay, so today a real quick video. Today we're going to be talking about sensor technology. Now, I went to Italy one time and one of my friends said, did you know that standard arcade sensors, so these are arcade sensors used in dance machines. This one's from a pump it up machine. You can see Andamiro on there. This is from a DDR machine by Konami, but the principle is the same. You complete a circuit here with two terminals, and when you squeeze the sensor, the circuit essentially completes and current can be passed through, acting like a switch, like a light switch on a wall. Similarly, over here we have FSR sensors here, Force Sensitive Resistors. As you squeeze the FSR here, it's a conductive polymer inside. So as much as you squeeze, the less resistance, again completing the circuit, but the resistance can change depending on how much you press on here. So my friend said, did you know arcade sensors are FSR sensors as well?
Hey Sean, did you know that arcade sensors are the same as FSR sensors? It's the same thing, just inside a rubber sausage.
If you connect one of these to a multimeter, you will see the resistance changes. And in a way, he's kind of correct, but for the wrong reason. So this is what I wanted to discuss in the video today. So let's hook these up to a multimeter and go through a very quick example. So here's a standard multimeter, very cheap multimeter. I have it on the ohm setting here. Right here I have it on 2000 kiloohms, which would be fine. And I'm going to show you pretty much how this works with resistance here. So if you imagine a circuit which is closed, so we'll put the probes together like that. You can see in resistance, a closed circuit, there's no resistance because current is flowing through the circuit. If I break the circuit, you can see the resistance goes off to infinity. Current cannot jump this gap right here, so that no current can flow through the circuit. So the resistance here, in this case, on a multimeter, 1, but essentially infinity. We close the circuit, current can pass through, there is zero resistance in the circuit. Now let's introduce a sensor into the mix. Okay, so I've introduced an FSR into the circuit here. You can see there's pretty much unlimited resistance here. The circuit is not complete because the FSR here has not been activated. If I press on the FSR here, watch what happens to the multimeter. You see, the harder I press on there, the minimal resistance there is. If I loosen up on here, you can see the resistance increases on the multimeter there. Until I remove, the circuit is open. The circuit is closed, and if I do kind of like a medium pressure, we can see a resistance value kind of in between. Essentially, that's how an FSR works. But wait, how does what my friend said apply to this? Well, let's connect one of these sensors, remove this FSR here, and have a look at the readings on the multimeter. Okay, so I've pretty much just chopped the end of a DDR sensor right here. Again, it's in the circuit in the same placement that the FSR was in before. We're showing an open circuit because the sensor is not pressed. Watch what happens when I press the sensor the entire way. You can see the circuit is complete. We have zero resistance, current can flow. If I loosen up just a tiny bit on this sensor, you can see it has a very similar output to what the FSR had. You see an open circuit, and we can see some kind of resistance values in between an open circuit and a closed circuit. So how can this be? Is this an FSR sensor? How does this work? Was my friend correct? Well, the answer is yes and no. Essentially, if you look at this object, you could say it is a force-sensitive resistor. You apply force to the object, the resistance changes depending on the pressure. Now, the only difference here is the technology used and the accuracy of these resistance values. But in the heart of everything, this is technically not an FSR sensor, but you could implement this DDR sensor into a system which acts and behaves like an FSR sensor. You could have an I/O like an Arduino or something and take resistance values off this sensor depending on how much pressure is inserted on here. But the difference between this sensor and this one is the technology used. Okay, so if you've never seen inside of a sensor before like this one, this is from a DDR sensor, but pretty much all of the arcade style sensors are similar. The two wires kind of come in here through there. Kind of looks like a little cheap necklace. They're all kind of linked together on little chain links. And they're surrounded by this conductive rubber here. These are these black strips. If you've ever opened up like a video game controller, like a PlayStation controller, Xbox, you'll see this same conductive rubber pressing down on the circuit board when you push the buttons. And the reason this rubber is conductive is because there's small conductive particles in there, like metal particles. It's like if you make a cheesy dough pizza, you roll the dough up with the cheese, you get like a cheesy crust, you know, very similar thing. So if I remove a little bit of that right there and do a resistance check all the way out here, you can see the resistance is 0.2. I move closer. You see the resistance changes depending how far away I am on this conductive rubber. This is where we're kind of getting that FSR type feel from. It's just pretty much the conductive rubber and how close you are in terms of proximity. So that's kind of how all that works there. And in terms of the kind of architecture of the sensor, so you see the two wires running inside the conductive rubber there. This is from the top of the sensor. It kind of sits like this. And in between there's a small bit of rubber there that sits vertically right there. So when you squish the sensor, this inner wall kind of squashes down, and then this conductive rubber, which houses the wiring, touches with this conductive rubber right here and bridges a connection across there. So when sensors start dying, which is actually quite rare, it's usually because of this inner wall right here is started to degrade. It happens in dry environments and things like that. So it's more so the inner wall. You'll notice if you try to remove a sensor without removing the L bracket and you kind of like, you're doing this to it, you're almost putting the sensor at a right angle. You're sort of destroying this inner wall here and making a constant connection between those things, destroying the sensor. It's very easy to destroy older sensors like that because the interior wall is already kind of deteriorated and dried out through time. But if you're curious, that's how an arcade sensor typically works and how we can get that FSR style feel using the conductive rubber that they tend to use in these types of sensors. So these FSRs are something you would see more with home pads, especially with in the groove setups and things like that. You don't really see them too much in the world of pump it up, where the players and arcades tend to stick with traditional arcade sensors like these ones here. But I have heard a lot of people say FSRs are crap, arcade sensors are the best, or vice versa. You know, a lot of things can change with that. The problem with FSR technology is the implementation of the technology. People take these raw FSR sensors and just shove them underneath metal in hardware where they can get easily damaged. This is not an implementation of FSR sensors. You know, you're buying raw parts. It's like using a computer and just not having a case for it, having a motherboard on your desk, and that's my computer. No, that's not really how the real world works. So a lot of people complaining about FSRs, it's mainly down to the implementation and how this is used. There are a lot of guides on the internet converting arcade pads to FSR systems, and the guides are absolutely awful. Yes, it works, but the way you're telling people to convert their pads using FSRs and sticking them in there and hoping it works and wondering why they have to change them out monthly or something like that is absolutely crazy to me. But that's sort of really, hopefully, demystified the myths surrounding arcade sensors like these here and FSR sensors like these here. They all have a purpose. It's all down to preference. I wouldn't say one is better than the other, but implementation of this goes a long way. Imagine if Konami or Andamiro had these sensors without the rubber and silicon. When you press the arrow on the pad, for example, you just have two metal contacts touch like that. It would be a horrible technology. I'm sure you would have stuck panels all the time, just like FSRs. You wouldn't really see this in an arcade environment, except with Stepmania X. But Stepmania X has a whole host of its own problems to deal with, let alone the FSR technology that they decided to use in their pads. Okay, so I hope you enjoyed the video. I love busting myths. I love getting out my equipment and actually putting these things to the test. The worst thing you can see is seeing everyone agree with each other on the internet, but they don't know why. In reality, there's maybe 3 or 4 guys that actually really know what they're talking about, and everyone else seems to copy what they say. You see that a lot. And the other popular one, which I might do a video on soon, is Stepmania will run on a potato. Stepmania will not run on a potato for many, many reasons. Okay, I hope you enjoyed the video. Stay tuned. More coming soon. Take care, guys.